For our project, we decided to use the things we learned in class and a few new formulas to show some practical applications of physics in swimming. First, we decided to use our knowledge of buoyancy to calculate the volume submerged of a person. To do this, we set the sum of the forces equal to 0 because when you're floating, you don't have any acceleration. So the force of buoyancy is equal to the force of gravity. Using the formulas for force of buoyancy and force of gravity, we found that when Jessica floats in water, she displaces 0.05 cubic meters of water. We also wanted to find the coefficient of drag, which is similar to the coefficient of friction for water. To do this, we made Jessica push off the wall and streamline until she stopped due to the force of drag. We used the distance she went and the time it took to stop to calculate her average acceleration and her initial velocity with the motion formulas. We then used sum of the forces equals ma to set force of drag equal to Jessica's mass and the acceleration we calculated. We got that the force of drag was equal to 41.5 newtons. We used this number and the formula for force of drag to calculate her coefficient of drag. We found that Jessica's coefficient of drag in water was 3.35.
Then we decided to calculate the force it would take for Jessica to swim front crawl at a constant velocity.
And go. We're now watching Jessica swim freestyle, and we'll see how long it takes her to get there. She's not swimming straight, but that's okay, right? How do you zoom on this thing? Oh, gotcha. Woohoo!
Go, Jessica!
Go, go, go!
Wait, there's some scuba divers over there.
Yay! Good job!
We did this by setting the sum of the forces equal to 0 because we assumed that the acceleration was 0. Since the sum of the forces was 0, the force of Jessica swimming was set equal to the force of drag. We then used the drag formula and the coefficient of drag that we found in the previous problem to calculate the force Jessica applied while swimming. Since Jessica was swimming front crawl, the area we used in the force of drag formula was the area of her arms and her head. We got the velocity we used for the formula from basic motion formulas and the time it took her to do one lap and the distance of one lap. Using these numbers and the force of drag formula, we calculated that for Jessica to swim front crawl at constant velocity of 0.91 meters per second would require 87.39 newtons. Lastly, we did similar calculations for Aaron swimming butterfly. Since his surface area submerged and velocity were different than Jessica's, the force it took for him to swim his butterfly was also very different than the force it took for Jessica to swim her front crawl. From our experiments and calculations, we concluded that when you swim at a constant velocity, the force you need to overcome the force of drag in water is based on the surface area submerged in water and the speed you're swimming at. Aaron and Jessica are different sizes and swam different strokes at different speeds, so their respective forces of drag and forces it took to swim were very different. When you swim different strokes, you have different values for the area submerged. For strokes where more of your body is underwater, you have to apply more force to overcome the greater force of drag. Similarly, the faster you swim, the more force you'll have to apply while swimming. This is interesting because in the motion formulas we did in class that only dealt with air, the velocity had no effect on force. We also concluded that water is very strong, and when swimming you need to apply a lot of force to overcome the force of drag that water supplies.